the videos are going to play through Explain Everything. However, I've also put the links to the video in your assignment if you wanted to ever watch them independently from the video that I'm going to upload of this lesson. Okay, so those are already in the assignment, but those video links that are already in the assignment are embedded into this presentation, so we'll work both directions with it, okay? So, here's the video.
Oh snap. 1, 2, 3, 4.
Sine, opposite hypotenuse sine.
Okay, write that down. Sine equals opposite over hypotenuse. Okay, write that down. Here we go, here's the rest. We'll keep going.
Opposite hypotenuse sine, opposite hypotenuse cosine, adjacent hypotenuse cosine.
Okay, write that down. Cosine equals adjacent over hypotenuse.
Adjacent hypotenuse cosine, adjacent hypotenuse tangent, opposite.
Write that down.
Dude, he had to memorize.
Adjacent tangent, opposite adjacent tangent, opposite adjacent. The long sides of hypotenuse and the other two sides depend on which angle you're focusing on.
Okay, so what he just said is really important, okay? The hypotenuse is always the hypotenuse. It doesn't ever change. It doesn't move. It's always across from the right angle. It's always the longest side, okay? So identifying the hypotenuse should be pretty easy. And what he just was singing about was the idea that the opposite and adjacent sides change depending on which angle you're at. If you're hanging out over at this angle here, the opposite side is going to be over here. But if you're hanging out at this angle up here, the opposite side is going to be there. So that's what he's singing about here, okay? And we're going to talk about that more in depthly here soon.
Pick one angle and look. There's one side that's the opposite. You can clearly see that there's also an adjacent side.
Okay, what does adjacent mean?
Next to.
Next to, okay? So the opposite angle, or the side opposite this angle, okay, you can just draw a line to it, and then the adjacent side touches next to the angle, all right? And we have to identify all three of these sides in order to find the trig ratios. And we'll talk more about that here in a second.
Sine, opposite hypotenuse sine, opposite hypotenuse sine, opposite hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse tangent, opposite adjacent tangent, opposite adjacent tangent, opposite adjacent.
Hey, you know what? And by the way, in case you haven't figured out why it's SOHCAHTOA, okay, so this is sine opposite hypotenuse. Cosine adjacent hypotenuse. Tangent opposite adjacent.
You were there.
Let's look at the next video, okay? It's not as entertaining. Okay, no, there's no singing. Shush, quiet. Quiet.
Now, before we start learning about we must learn three things about this right triangle. Now, the reason I know inside a right triangle is because of this little box. This little box serves as an indicator that this angle is 90 degrees. Now, let's learn something about the side. A right triangle has one side that is longer than the other two. Now, if you can't tell which side is longest just by looking at your right triangle, try doing this. Locate your 90-degree angle and look opposite. This side is the longest side of This side has a special name. It's called the hypotenuse. Hypotenuse. Hypotenuse.
He's just gonna leave the E
Now,
out.
the name of the other two sides depends on which angle we're talking about. Say, for example, we're talking about this green angle. If we're talking about this green angle, then this side is next to it. Another word for next to is adjacent. This side is adjacent to the green angle. This side is still your hypotenuse, which makes the bottom side opposite. The bottom side is opposite to the green angle. So there you have it. Hypotenuse, adjacent, and opposite. When we're talking about the green angle. Now let's talk about the yellow angle. This side is next to the yellow angle, which makes this side adjacent. This side is adjacent to the yellow angle. This side is still the hypotenuse, so that makes this side opposite. This side is opposite to the yellow angle. Now let's start learning the trigonometric ratios by using an acronym to help us remember. An acronym is a word that stands for something. The acronym that we use is SOHCAHTOA. SOHCAHTOA.
Now, here's another reasons why I like this video. So he writes it a little bit differently so that you can immediately understand that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent opposite over adjacent. I think this is useful as well, and if you find it useful, I would say write it down.
So, sine of x equals the opposite side over the hypotenuse. Cosine of x equals the adjacent side over the hypotenuse. Tangent of x equals the opposite side over the adjacent side. Okay, we are ready to do some math. Now in this problem, we are asked to find the measure of the green angle. It's a good idea to start by identifying the three sides first.
Okay, so I'm going to stop there because it's going to get into actually finding the measure for angle x, and we're not doing that today, okay? We're going to do some other things with it today. Now, any questions so far? Okay, so as we've already seen in all the videos, okay, when we're looking for the sine, the cosine, or the tangent, it's going to be opposite over hypotenuse. And over here, these are the abbreviations, and this is how they are put on your calculator: sine, cosine, tangent. Please don't say sin, cos, tan. That's just not a thing, and I don't want you to use that kind of terminology. I want you to actually say the entire word: sine, cosine, tangent. The thing that you don't know at this point is that there are three other trig functions, okay? And so what I want you to do is you're going to write these down, the three other trig functions, and they are all just reciprocals of these, okay? Here are the other three trig functions, okay? This is new. The reciprocal of sine, so it's hypotenuse over opposite, is cosecant, okay? The reciprocal, yes, the reciprocal of cosine is the secant. And so that's just hypotenuse over adjacent. And the reciprocal of tangent is cotangent. Okay? So those you're going to need to write down. These are the abbreviations for them. They are not on your calculator. Okay? But there are 6 trig functions. I know that many of you have learned these 3. There are actually 6. And somehow you're going to have to make a connection between sine and cosecant to realize that they're reciprocals. Cosine and secant to realize that they are reciprocals. Obviously, cotangent and tangent is pretty easy to realize that those two are reciprocals. So that is not a 0. This is a Greek letter theta. Okay, this correct, from mu alpha theta. Okay, this letter represents the measure of the angle. So what this is saying is sine of whatever the angle is opposite over hypotenuse. Now, sometimes that measure will be, there won't be anything here. If I would have said sine of B, because this B is angle B, then that would have still meant the same thing, okay? But this is the Greek letter theta.
It's theta now.
Yeah, theta. Theta. Theta.
Theta cheese.
No, not. That is theta. Theta. Okay. All right, let's get into some examples of the problems that you're going to be doing today. Okay. And some of the problems kind of look like this. If you want to take a picture of this screen, go ahead. I'm gonna show you how to go through and do a problem like this. Okay, so the directions are going to say something like this. Find the values of the 6 trigonometric functions for angle A. Okay. And as you can tell, we're missing one of the sides. Right? But what we can do at this point is come up with, based off of the sides that we're given, we can make a determination about one of the 6 trig functions right now. Okay? So we're talking about angle A, which means we are over here. We are positioned at that angle. All right? So in terms of determining opposite adjacent, you have to do it as if you were positioned over there at angle A or angle theta. Okay? So the first thing I like to do is label all the sides. Hypotenuse, opposite, adjacent. Which one is the hypotenuse?
17.
Okay. What is 15?
Adjacent.
Adjacent. Okay. So in this situation, I have the hypotenuse, I have the adjacent side. I don't know the opposite side yet. Because I'm given the adjacent and the hypotenuse, which trig function involves the adjacent and the hypotenuse?
Cosine.
Cosine is adjacent and hypotenuse. Okay? Which also means secant is also hypotenuse and adjacent, but we'll get there in a minute. So the cosine of angle theta is the adjacent over the hypotenuse. So it's going to look like this. The cosine of theta is 15 over 17. That's the one thing we know right now. Okay? Because that's all I know, in terms of the sides, adjacent and hypotenuse, I still need to find the opposite side. And the reason we spent so much time on Pythagorean theorem is so that we can do something like this. Okay? So what I want you to do is go ahead and find the opposite side. Do that now. Please go. Alright, so the opposite side, you're going to find that this way. Since 17 is the hypotenuse, we're going to go 17 squared minus 15 squared. What is the opposite side then?
8.
Okay, so that side is 8. Now that I have all the sides, I can find the remaining trig functions. Okay, and so what I would tell you to do first is just find the sine, cosine, and tangent. Find those 3 first. Okay, so go ahead and do that. Sine, cosine, and tangent. So sine is opposite over hypotenuse. So what's the sine going to be?
15 over 17.
Nope.
8 over
Oh,
17.
8 over 17. Okay. Cosine we already have. What's the tangent going to be?
8 over 15.
Okay. So here's what you should have had. Okay. Now I'm going to say this, and I want you to hear it loud and clear. Whenever you're asked to find a trig ratio or a trig value, your fraction must be reduced as far as possible. In this case, these 3 are already reduced, but I'm warning you, if you don't reduce those fractions when we get to a quiz or a test, you will lose points. Make sure those fractions are reduced as far as they can. Now, to find the other 6, the other 3, what is the reciprocal of the sine?
17 over 3. Oh, you mean...
What's the name of the function?
Cosecant.
Cosecant.
Secant.
What's the reciprocal of the cosine?
Secant.
Secant, and the reciprocal of the tangent.
Cotangent.
So once you find these 3, you just have to flip them and remember what those other 3 are to get them. Okay? So those are the other 3. Cosecant of theta is 17 over 8. Secant of theta is 17 over 15. And the secant of cotangent, or cotangent of theta, is 15 over 8. And yes, you have to put the angle there. If there wasn't a theta, you'd put A, cosecant of A.
Why do you need this?
It's the next kind of problem that you're going to see in your homework today, okay? Are there any questions before we move on to the next one?
Yes, don't move.
Here's the next problem that we're going to be looking at. You're going to get a situation like this. Sine B is 5/8. Find the exact values of the 5 remaining trigonometric
Oh, so
functions
plug
for
it in,
B.
you gotta plug it in.
Now, when it says exact values, what they're saying is don't give me decimals. Simplify as far as possible, okay? And you're going to have problems like this in your homework today. Here's the thing that you need to know. Sine is, what's the definition for sine?
Sine is opposite hypotenuse.
Okay, so what I have actually here is, and if you want to draw the picture as you work through these problems, you're welcome to do that, or draw a picture. You don't have to, because the side that I'm missing, if this is opposite a hypotenuse, what side am I missing?
Adjacent.
I'm missing the adjacent side, and I need the adjacent side. And when I have all 3 of those, then I can find the 6 trig functions. Okay, but if you want to draw a picture of the triangle or of a triangle, you can.
That was a slobber.
Here's something that's really important.
I'm sorry.
Something that you need to keep in mind whenever when you see triangles, okay, that I'm going to point out to you right now. The angles will always be labeled with capital letters. Their opposite sides will be labeled with the lowercase. So this would be side A, this would be side B, this would be side C, okay? So that's something to pay attention to. Now, you don't, like I said, we don't necessarily have to draw a triangle for this problem, because I know the side that I still need is the adjacent side, okay? I've got the opposite side, I've got the hypotenuse. So go ahead and find the adjacent side. And since it's in an exact value, you just want to not use decimals. All right, now, in order to find the adjacent side, okay, you're going to use Pythagorean theorem again, all right? And this time it doesn't turn out so nice, okay? And so 64 minus 25 is 39, and that cannot be simplified. The square root of 39 doesn't have any perfect squares that go into it. So that's all you can do. And so when it says exact values, we just leave it in simplified radical form. If this could be simplified further because there was a perfect square that was a factor, we'd do that, but in this case we can't. So what I want you to do now we have all the sides. We have the opposite, the adjacent, and the hypotenuse. Find the 5 remaining trig functions, because now you have all the sides. Do that now, please, go. Now our angle is angle B, okay? Not theta, angle B. One of the things that I like to do before I get too far along is I like to write out what I'm looking for. So I left off the sine because we already have that. But that way, and if I keep things across from each other, I know which ones are reciprocals of which ones. Okay? Makes it a little bit easier, makes it easier to stay organized, and it's helpful in terms of learning these 3 if you kind of keep them across.
Why do you have a radical like on the bottom?
Good point.
Oh God,
We'll get
we
there.
have to do more.
Oh,
So let's take a look. Here's what we got so far, okay? Here's what we got so far. And this is what you should have. Okay, so take a look up there. How many had those 5 correct? Okay, now Bella brought up a good point. I thought you can't have square roots in denominators. You can't. So you need to rationalize the denominator. Okay, so go ahead and do that. So if you recall, in order to get the square root out of the bottom, I just have to multiply top and bottom by the square root of 39, because then it'll be the square root of 39 squared, and so those radicals will cancel out. All right. So here's what that would look like. So on both of those cases, I multiply top and bottom by the square root of 39. Notice over here, the square root of 39 times the square root of 39 is just 39. 5 does not have any factors that go into 39, so that's as far as I can go here. I do the same thing over here with the secant. There is not a common factor between 8 and 39, so that's as far as I can go. Watch out for problems like that. When it talks about exact values, what it's saying is don't go plugging this in the calculator and give me decimals. Leave it in simplified radical form. Okay, so you just had a little extra step beyond there that we'd done earlier in this year to get the radical out of the denominator. Okay. Any questions about any of this? So here's what's gonna happen, okay? So today we're just gonna practice working with the 6 trig functions. On Friday, we're gonna learn how to find the measure of a missing angle. And then on Monday, we're gonna find out how to find the length of a missing side, okay? And then a week from Friday, we're gonna have a quiz over all Pythagorean theorem and the trig functions, okay?
So next Friday.
Next Friday, yes. Not 2 days from today, a week and 2 days away from, okay?